not going into those topics. So whichever you can take, you can easily solve those problems and you can score. So that I am taking. Okay. So we are going to third block. If time is there, even we'll see the fourth block also. Okay. So in block 3, unit 7, we have elementary transformations. Okay. So for this elementary transformations, we have some rules are there. Okay. So the main aim is to find the rank of the matrix. So for finding the rank of the matrix, we apply the elementary transformation, or we call it as elementary operations. Okay. So in that first rule is that interchanging two rows or two columns. Okay. So for finding the elementary transformation, we use either 3 by 3 matrix, that is a square matrix, or rectangular matrix, 3 by 4 matrix, or 4 by 4 matrix, any matrix. Okay. Further, to convert the given matrix into the equivalent matrices. If 4 by 4 is there, means to convert it into non-zero matrices, non-zero rows. Okay. That's why we apply the elementary transformations in that. So first condition is that first rule we apply is interchanging two rows or columns. Means any row, if 3 by 3 matrix means row 1, row 2, row 3 will be there. You can interchange row 2 as row 1, row 3 as row 2, or row 3 as row 1, like that, anything. So that interchange will be there. And second rule we apply is multiplying all elements of a row or column by a non-zero scalar. Okay. So any row, either first row, second row, or third row, you can multiply with non-zero scalar, means any. If first row you have 1, 2, 3, 4, like that, and second row if you have 2, 3, 4, 5. Okay. To make it into to apply the elementary transformation, second row 2 is there, no? So with the help of the first row, if you do the subtraction, then we multiply first row with 2. Okay. To make that one as, see, like this it is a, so any 3 by it is the 3 rows are there and 4 columns are there. Okay. So first one is you can interchange any one, either this row as this row, or this row as this row, this row as this row. Okay. So if in some cases here 1 is not there, here 1 is there, and here 8 is there, something. But in when you are converting the matrix to any echelon form or normal form, that here whatever the element is there, first row, first element, it should be 1. Okay. So to convert that one, here you can interchange this row as this one. Then you can, if you write here, you will write it as R1 as R2. This is the how we'll write the elementary operations. Even you can put like this. For what row you are doing, for R1 row, you are interchanging R1 as R2. So this R2 will become here. So 1, 3, 5, 6, 8, 2, 3, 4, 3, 4, 5, 7. Okay. So first element we are making it as 1. Okay. Now you have to make this as 0 and this as 0. Okay. So whenever we'll do, the main aim to find the using of elementary transformations is to find the rank of the matrix. Okay. So for that purpose, to find any rank of the matrix, we may convert the given matrix into echelon form or normal form. Okay. So echelon form means it will be in the form of like this. So if you take this one, 1, 3, 5, 6, you have to make this as 0, 3, 4, and last row. So last you may get here 0, or you may have here any one element. Okay. So if you have here all zeros, that means you have to make here this as a triangle. So this triangle as 0, 0. If you are having here element up till here only, you will get the triangle. Here you will get the 7 as a number. Okay. So then we'll find what is the rank of the matrix, is how many non-zero rows are there. So if it is becoming 0, then we have only 2 non-zero rows. This third row has become 0, and here these 2 you have the numbers are there. So here rank of the matrix is 0. Okay. So conversion of echelon form means whatever the matrix is there, that matrix should be converted into like this form. First element should be 1, after that 0, after that 0. You may become, that means in some cases, the last row, it will become whole, the whatever the elements are there in that row, they will become 0. Or in some cases, you may not get all zeros, but forming of the triangle like this is called as a echelon form. First element 1, 0, 0, 0. So if you have matrix like this, even you can convert like this also. So it is based on the given matrix. Okay. So like this means you will get here triangle C. Okay. This is also the conversion of the rank echelon form. So now how many non-zero are there? 1, 2, 3. So then the rank of the matrix is here. Rank will represent with R or like this row. Row of A is equals to 3. If this is also become 0, 0, then the rank of the matrix is 2. So these 2 has become the 0, 0. Okay. So echelon form will do with the only, so column operations will be there, and also row operations will be there. 2 types of operations will do elementary transformation, rows and also columns. So to convert any given matrix into echelon form, we will use only row transformations. That means we will not use the column transformations. Whenever it is the normal form, we will convert the given matrix with the help of both row and column. Why? Because we have to convert the matrix into identity matrix. Okay. So whatever this matrix is there, you have to convert this into identity matrix. Okay. Like the matrix may be either 3 by 3 identity matrix or 2 by 2 identity matrix. In some cases, even you will get the 2 by 2 identity matrix. That means here you may convert it as I2 0 0 0. That means it is identity matrix of 2 by 2, and it may be I3 0 0 0. Okay. So when you are converting the given matrix into identity matrix, whether if you are converting it to 2 by 2 identity matrix, then the rank of matrix is 2. If you are converting the given matrix into 3 by 3 identity matrix, then the rank of the matrix is 3. Okay. So the main concept of this finding the elementary transformations is to find the rank of the matrix. Okay. So here either we can first, here conversions is there, no, like this form or like this form. You have to, if all the elements are like this, then you have to make this as 1 and all other elements 0. Here 0 1, these two 0, here 0 0 1, and this is also 0. To do the conversion of all these elements into zeros and 1, first thing is, if any interchange is possible, means we'll do the interchange of 2 rows or 2 columns. Second one is multiplying. Here to find, we have interchange, no? So to make this as 0, we have to multiply this row 1 with 8. That means 8 minus 8, you will get here 0. Even this also, 3 minus 3, you will get here 0. Okay. So that is the second point. Multiplying all elements of a row, you can multiply all the elements of the row. And third condition is that you can do the multiplication of this element and you can add them. Okay. So third one will be addition of or subtraction of 2 rows. Okay. First condition is interchange. Second condition is multiplying with any non-scalar. And third one is we have to do the addition of those 2 rows or columns. Okay. So, and in this only we have the concept. First one is finding the rank of the matrix. So just if it is a small one, you will get for 5 marks, finding the rank of the matrix. Or if he is asking in the question that find the rank of the matrix with by converting, or we call it as reducing to normal form. Okay. So that will be the lengthy problem. It will be asked for 10 marks question. And for easy thing to find the rank of the matrix is, okay, if any matrix A is given, So if it is having only one single element, it is called as 1 by 1 matrix. That is, it has one row and one column. Okay. So then simply only one element is there. Therefore, we can tell here rank of the matrix A is 1. Okay. So for any matrix, the rank will be depending on the rows and columns. Okay. So how many rows are there and how many columns are there? It mainly depends on the how many rows are there. Okay. Here one row is there. So the rank of the matrix is 1. Okay. So the rank of a matrix will be never, it will be 0. Rank of the matrix will never be 0. Only in case of if the rank of a matrix, that is if the matrix given is null matrix of 2 by 2 you have it. Okay. So then only rank A equals to 0. So rank of null matrix or 0 matrix is equals to 0. Only in this case only you will have the rank as 0. Okay. So other than that, if you have any 3 by 3, that is 3 by 3, 2 by 2 or 1 by 1, 4 by 4 or 4 by 3 or 3 by 4, that is a square matrix or rectangular matrix, you will have compulsory any one, that is it may be 4, 3, 2, 1. Okay. Any depending on the order of the given matrix, you will get the rank of the matrix. Okay. So for finding the rank of matrix of different order of the matrices, you have different rules are there. Okay. So you may get this question as short also, that is objective type also. Any small matrix will be given and they will ask what is the rank of the matrix. Okay. If you have 2 by 2 matrix also, so if it is 1, 2, 3, 4 is there. So he is asking to find the rank of the matrix of a 2 by 2 matrix. So you will have all the conditions will be there. So directly we can't tell if the rank of the matrix of this one is 2. Okay. So for that first condition is if determinant. I hope you know this symbol, how you write as a mod. It is called as a determinant of the matrix. If determinant of the matrix is not equals to 0, or we call it as a non-singular matrix or non-zero. That means you are not getting as a 0 here. Non-singular matrix, that is determinant of this matrix. If it is not equals to 0, then rank of 2 by 2 matrix is equals to 2. Okay. You can see here determinant of A is, that is if it is 2 by 2 matrix, just we find the cross multiplication. So 4 minus 3 2 is 6. It is equals to minus 2, not equals to 0. Okay. So here rank of A is equals to 2. Okay. So if we take another example, if it is equals to 1, 2, see like this if you have. So 1 minus 2. Okay, if you take the same one, that is 2 minus 2 you are getting. So determinant of A is equals to 2 minus 2 you are getting 0. So then in this case rank of A is equals to 1. Okay. So conditions you see. Okay. So first one is, that is 0 matrix. This you will get as an objective type question. So what is the rank of a null matrix or a 0 matrix? So it is 0. So rank of 1 by matrix is 1. So if it is a 2 by 2 matrix, then we have two conditions are there. Okay, first one is if it is non-singular matrix, that is determinant of A is not equals to 0, then rank of 2 by 2 matrix is 2. And if determinant of A is equals to 0, then rank of matrix is 1. Okay. So this is for 2 by 2 matrix. So if you go for the 3 by 3 matrices, So if it is 3 by 3 matrix, okay, a 3 by 3 matrix, first condition is that if determinant of A is not equals to 0. Same, if the determinant of A is not equals to 0, then rank of A is equals to 3. Okay. So if determinant of 3 by 3 matrix is 0, not equals to 0, then rank of A equals to 3. And if determinant of A is equals to 0, okay, if determinant of A is equals to 0, then we have to find all minors. Then find all 2 by 2 minors. Minus means, I hope you know, that is, if you take 3 by 3 matrix like this. So like this, you have the matrix. This is the minor one with order 1 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the minus, if you take out like this 2 by 2 matrices. So minus will be of 2 by 2 order, or also 3 by 3 order also. Okay. So here if it is a 2 by 2 order means 1, 2, 4, 5. And here 2, 3, 5, 6. Next 4, 5, 7, 8. And 5, 6, 8, 9. Like that only you can take this one and this one. And this one and this one. Like this. Any 2 by 2. The matrix with the order 2 by 2 is called as a minor of the matrix. 3 by 3 matrix. Okay. In 2 by 2 matrix, you will have the minors with 1 by 1 order. In 3 by 3 matrix, you will have 2 by 2 minors. And in 4 by 4 matrix, you will have even 3 by 3 minors and also 2 by 2 minors and also 1 by 1 minors. Okay. Like this. So if a determinant of the matrix is not equals to 0, then rank of A equals to 3. And second one is, if determinant of A equals to 0, then find all 2 by 2 minors. Okay. If in that you are taking all the 2 by 2 minors, if you are getting any one, okay, if any determinant of A 2 by 2 if any 2 by 2 matrix you are getting not equals to 0, if any 2 by 2 you are getting not equals to 0, then order of A is equals to 2. Okay. If any 2 by 2 is not equals to 0. Okay. So you may get here almost, I think so, you will get all not equals to 0 only. 5 minus 6 means minus 1. 6 2s are 12. 12 minus 15 means you will get as minus 3. In this example, you will get all not equals to 0. Okay. So by taking any matrix A, if you are getting the determinant as non-zero, then we call the matrix, rank of the matrix as 3. If you are getting as 0, then find all the minors of the matrix. So in that, in some cases, it is depend on the given problem. In that problem, if you are getting all minors as 0, okay, third condition in this only will be there. So for a 3 by 3 matrix, you may get the rank as 3, R2, R1. Okay, it is not compulsory that you may get only 3 or 2. Even you may get the rank as 1 also. So first condition is, if the whole 3 by 3 matrix is not equals to 0, you will get 3. If you are getting A mod A equals to 0, then find all 2 by 2 minors, in which if you are getting any one as not equals to 0, then you will get the rank as 2. Okay. So if you are getting here all 2 by 2 matrices as 0, even you are getting 2 by 2 matrices also 0, then you will get the rank of A is equals to 1. So in this only third case is also there. First one, determinant of A, if you are getting 0, and in the 2 by 2 not equals to 0, rank is 2. If all 2 by 2 matrices is also equals to 0, then we will get the rank as 1. Okay. So this is the case for the 3 by 3 matrix. So similar one is, one example you can take here. See, matrix A is equals to Okay, this is the given matrix. So we don't know what is the rank of the matrix. First thing is find the determinant of this one. That is determinant of A is equals to 3 by 3 matrix. You know how to find the determinant, no? So you eliminate the first column and also first row, and then you find the minor of that one. That is 1 into 3 to the 6 minus 8. Second element is the negative one. Next one 4 minus 4. Next 3 into 2 to the 4, 4 minus 0. So you will get it as here minus 2. This is 0. This is 4 to the 12. So you are getting plus 10 here. So okay, this is non-zero you are getting. So it is not equals to 0. So we can tell here rank of A is equals to 3. Okay, this will be the simple 5 marks problem, or even they may ask this as for the multiple choice questions. Okay, so here in the exercise or you check your progress, they have asked to find the rank of the matrix by reducing the given matrix into echelon form. Okay, so when you reduce the given matrix into echelon form, then how many non-zeros are rows are left in that matrix, then that is called as a rank of the matrix. Okay, so in this only same similarly, if we have the 4 by 4 matrix, so 4 by 4 matrix also same here. Determinant of A, if it is not equals to 0, then rank of A is equals to 4. Okay, so if determinant of A equals to 0, determinant of A equals to 0, then we have to find 3 by 3 minus. Okay, find 3 by 3 minus. So in which same 3 by 3 is, if it is not equals to 0, then rank of the matrix will be 3. Okay, so if it is a 4 by 4 matrix, means you may have chance of 4 as a rank, R3, R2, R1, but you have to know which is the rank of the matrix. Okay, so next same, if you are getting the 3 by 3 as 0, then find 2 by 2. If 2 by 2 is not equals to 0, then rank of A will be 2. If 2 by 2 is equals to 0, then you will get rank of A equals to 1. So like this process will be there. So first condition is if it is non-singular, any matrix 4 by 4 or 3 by 3 or 2 by 2. So if it is not equals to 0, non-singular, then the rank of the matrix will be number of rows in the given matrix. Here 4 by 4 means the rows will be 4. So the rank of the matrix is 4. So if it is equals to 0, find all 3 by 3 minus. So then you will get this one. So here this whatever the short trick is there to find the rank of the matrix, these you will use for finding any multiple choice questions, or after this you have the problems are there for finding the echelon form and also normal form. So normal form is you have to convert the given 4 by 3 matrix or 3 by 3 matrix or any matrix into identity matrix. So you have the process will be very lengthy one. No? We will use the elementary transformations in that. So before, if you know what is the rank of the matrix A, then easily you can convert the matrix into whether it is a 2 by 2 identity matrix or 3 by 3 identity matrix. Okay. So before, if you know the rank, we have the procedure this one. Okay. If you know first only 4 by 3 matrix is there. So in that, if you know the rank is 3, then you can convert the matrix into 3 by 3 identity matrix. Okay, and also for lengthy process of finding echelon form or normal form or any matrix converting into any matrix converting into that is equivalent matrices. So this is the short trick you have. Okay, so first problem we'll see finding the rank of the matrix by converting the echelon form. Okay, in the question itself they may mention that find the rank of the matrix with by reducing it into echelon form. So we'll see one example in this. So in check your progress, you have page number 79. Find the rank of the following matrices. Okay. So first one is 2 minus 2 0 6 4 2 0 1 minus 1 0 3. Okay, this is the given matrix A is equals to this one. So here when we apply the elementary transformations, or they are called as row operations, or E of transformations, or E operations, anything, but they are all are same only. Okay, so here we'll represent this as R1, R2, R3, R4. This is C1, C2, C3, C4. But to convert the given matrix into echelon form, we will use only the row operations. Okay, so here first I have told for the echelon form, you have to get here 1 0, here 0 0, you may get here 0 or not, but here 0 0 0 0, even you may convert this as 0, or it depends on the rank of the matrix. Okay, so last row you may make it as a whole 0, and here 1 and zeros. That means whatever the triangle you are getting here, upper triangle, you have to, that whatever the triangle is there, that should be all zeros. Okay, so now first we need this as 1. No, you may interchange this R3 as R1. Okay, so R1, you are doing it as R1, you are interchanging as R3. Okay, this is the first condition. So you may have here 1 minus 1 0 3. Okay, 4 2 0 2. Next 2 minus 2 0 6. Next 1 minus 2 1 2. Okay, first thing we got this as 1. Okay, this you have to make 0, this one and this one. Okay, so here we can divide this by 2 and this also by 2. So that is R2 by 2 and even R3 by 2. Okay, so then it will be 4 means 2 1 0 1. This is 1 minus 1 0 3, and this is 1 minus 2 1 2. Okay, now you even this division whatever you have done, you may do that one, or directly you can do the subtraction of these two, you will get as 0. Okay, now the thing is you have to make this as zeros, first one. So you may apply here this is R2 minus 2 R1. Okay, for R2 we are applying R2 minus 2 R1. For R3 we are applying R3 minus R1. Okay, at a time we can do any that is we can do at a time 3 operations also. Here for this 3 operations we are doing. Okay, next last one is R4 minus R1. Okay, so if you apply these 3 operations, you will get it as 1 minus 1 0 3, 2 minus 2 is 0, 1 minus of minus is plus 2, means you will get it as 3. This is 0. Now 1 minus 6 means you will get minus 5. Next 1 minus 1 is 0. Minus 1 minus of minus is plus 1 0 0. Next 3 minus 3 is 0. So we got this as 0. Why? Because it is similar as R1. Okay. See, both are same. So when you add them, you will get it as 0. So this next R4, what we are getting? 1 minus 1 0 minus 2 plus 1 means minus 1. This you will get just 2 plus 1 minus 1. 1 minus 0 is 1. 2 minus 3 is 1. Okay. Here already one, whatever the row is there, that has become 0. If you will take that row to R4, if you interchange that R3 as R4, you will get the upper triangular, no? That means 1, 0, 0. Here all zeros you will get. So that is R3, you are converting as R4. So 1 minus 1, 0, 3, 0, 3, 0, minus 5, 0, minus 1, 1, 1, 0, 0, 0, 0. Okay. So here we got this as like this triangle. Even if you want, you can make this as 0. Okay. So that is R3. This you have for this one. Minus 1, minus 1 is there. Keep like that only. How many non-zero rows we got here? So non-zero rows are this one, and this one. So this last whatever it is there, this row has become 0. That means fourth row has been eliminated. So here the number of non-zero rows are 3. So therefore the rank of the matrix is 3 here. Number of non-zero rows is equals to 3. Therefore, rank of matrix is equals to 3. Okay. So like this here, you may, what will happen means if you add these two, you will get again here you may get 0. But when you add with R1, you will get here 1 again. So it will be lengthy process. Either you can convert like this also. That is, first you divide R2 by 3. So 1 minus 1, 0, 3, 0, 1, 0, minus 5 by 3. Then you will get 0, minus 1, 1, 1, 0, 0, 0, 0. So if you want to make it as an upper triangular, we can use this one. Now you can do R3 as R3 plus R2. Here also we will get the same one. 1 minus 1, 0, 3. Okay, 0, 1, 0, minus 5 by 3. So 0 minus plus is 0. 1 we get as same. 1 minus 5 by 3 by 2. 1 minus 5 by 3 means 3 minus 2 by 3 you will get. And last one is 0, 0, 0, 0. So now also see 3 non-zero rows are there. 1, 2, 3. Here you have last two elements, no? So like this, to get the whatever the triangle, upper triangular is there like this. This conversion is called as echelon form. Okay. So 1 z, this whole whatever the row column is there, that column first element should be 1. After that all zeros. Here last row you may make it as zeros. Okay. If it is a 1, 2, 3, 4, we have 4 by 4 matrix is there. If it is 3 by 3 matrix, 3 by 4 matrix, then you may get this whole whatever is there, it will become 0. So you will be left with only 2 non-zero rows. Then the rank of the matrix is 2. Okay. So here like this you may convert. If you will do directly here also, we have 3 non-zeros. We can stop here. Or else, if you want to make it as like this triangle, you do this again 2 steps. So we will get the same one, 1, 2, 3 non-zeros. Number of non-zeros equals to 3. Therefore, rank of matrix is 3. Okay. So the procedure is the same one. In some cases, you may get all zeros also. This one also zeros. Then also, how many non-zero rows are left? That is only called as a rank of the matrix. Okay. Next, in this only we have the topic. Next one is reducing the given matrix into the normal form and and finding the rank of the matrix. So in the question they will mention that reduce the given matrix into normal form and find the rank of the matrix. Okay. Reduce the question you have in your textbook. So reducing the given matrix into normal form will be the 10 marks question. Okay, they will ask for the 10 marks question. So like this, it will be there. Reduce the matrix A. One, zero. Okay, like this, any. So compulsory for the normal form, you have the rectangular or square matrix of 4 by 4 or 4 by 3 or 3 by 4. Okay. So reduce the matrix A into normal form and hence find the rank of rank of A. Okay, like this the question will be asked. It is for the 10 marks question also you will get in the examinations. Okay. So now it is 1, 2, 3, 4. 4 rows are there, 4 columns are there. Okay. If you want before only to know the rank of the matrix, you can use the whatever the rules I have told now starting. It is a 4 by 4 matrix. So first you find the determinant of the matrix. If you are getting it as not equals to 0, then the rank of the matrix will be 4. Okay. So if you are not getting as determinant as 0, that is if you are getting equals to 0, then you find all the minors. Okay. That is one method. And another thing is we can find with the help of the elementary operations row and column normal form. For normal form, we'll use both the rows and column operations. But for echelon form, we'll use only the row operations. You remember that one. Okay. Now you have to make whatever this is there, you have to convert into identity matrix. So first you have here 1. So no need of doing the first rule, that is interchange of rows or columns. Next here already 0 is there. So you have to make this as 0 and this as 0. Okay. So for this one, see. So A equals to 1, 0, 2, 1, 0, 1, minus 2, 1. 1 minus 1, 4, 0, minus 2, 2, 8, 0. Okay. Here see, whatever the last row is there, you can divide it by 2. Okay. So it will be somewhat simpler form we can convert. That is R4 is divide R4 by 2. So you will get it as 1, 0, 2, 1, 0, 1, minus 2, 1. 1 minus 1, 4, 0. Last one is minus 1, 1, 4, 0. Okay. Even again to make it as a very simple one, even here C3 is there, no? C3 you divide by 2. Or else you can keep like that only, you can do the subtractions here. So 1, R3 minus R1. and R4 minus R1. Or else see R4 minus R3 we can do. So 1, 0, 2, 1. R2 we are keeping like that only 0, 1, minus 2, 1. So 1 minus 1 is 0. Minus 1, 0 is minus 1. 4 minus 2 is 2. Next 0 minus 1 is minus 1. Next these two no. 1 minus 1 is 0. 1 minus 1 is 0. 4 minus 4 is 0. Next 0 minus 0 is 0. Okay. So now this is up till here it is 2 by 2 identity matrix. If the rank is 2, you have to make all the elements as 0. If it is 3 by 3 matrix means you have to convert this 2 as 1 and this as zeros. Okay. Now here you make these all zeros. For that C3 you divide by 2. Okay. You get it as 1, 0, 2, 1. Sorry, dividing by 2 no. So you will get as 1, 0, 1, minus 1, 1, 0, minus 1, 1, minus 1, 0, 0, 0, 0. Okay. Subtraction 0. R4 by 2. So we got minus 1, 1, 2, 4, 0. Okay, R3 is R3 minus R1. 1 minus 1 is we got 0. Minus 1, 0 is minus 1. 4 minus 2 is 2. 0 minus 1 is minus 1. Okay, R4 minus R3. In minus of minus no, here you will get minus 2. Okay, here we go. R4 minus R1 only you do. See, addition we have done there wrong that. Okay, 0, 1, minus 2, 1. Next R3 what we got? 1 minus 1 is 0. Minus 1, 0 is minus 1. 4 minus 2 is 2. 0 minus 1 is minus 1. Here minus 1 you can add no then. So R4 plus R1. So it is 0. 1 plus 0 is 0. 4 plus 2 is 6. Next 0 plus 1 is 1. Okay. Now so here whatever C3 is there, C3 by 2 you do. So you will get it as 1, 0, 1, 1, 0, 1, minus 1, 0, minus 1, 1, minus 1, 0, 0, 3, and here 1. Okay. So now if you add these two, R3 and R2, you will get this whole thing as 0, no? So R3 is R3 plus R2. So what you will get? So here whatever I am applying the operations, that is only the procedure, you may not think. Okay. So you can use any other operations and you can convert this into identity matrix. Okay. So whatever the operations here, column or row have applied, no need of following that one. Okay, you can use any one, but the thing is you have to convert the given matrix into identity matrix. Okay, now if you do that, what you'll get? 1 0 1 1 minus 1 1. So this and this, no, 0 minus 0 is 0, plus we are doing minus 1 plus 1 0, 1 plus 1 0, minus 1 plus 1 is 0. Next 0 0 3 1. Okay, now you can interchange here, that is R3 you are converting as R4. Then just to make it as an easy one, last row it will become whole 0. So 1 0 1 1 0 1 minus 1 1 0 0 3 1. Last it has become all zeros. Okay, now this part has become zeros. Now this one it should be 0, and the here 0 0, and here you have to get 1 if it is a 3 by 3 matrix. Okay, so now we can, that is, this is C4, no? C4, you apply C4 minus C3. Next 1 minus 1 0. Next C3 as C3 minus C1. Okay, so it will be 1 0 C3 we are doing C3 minus C1. So 1 minus 1 is 0. This is 0, this is 0, this is 0. 1 0 0. Minus 1 0 means here minus 1 only. Next 3. Next 0. Next C4 minus C3. So C4 minus C3 means this is 1 minus 1 0. 1 minus of minus means what you will get? Okay, 1 plus 2 you will get, and this is C plus C4 minus C3. So 2 you will get. Next this is zeros. Okay, see once again check this one. C4 you are doing as C4 minus C3. So 1 minus 1 is 0. 1 minus of minus. So it will be 2. Next 1 minus 3 means we will get here minus 2. Okay, C4 minus C3. Okay, so 1 minus 3 means minus 2. 0 minus 0 is 0. For C3 what we have done? C3 we have just subtracted C1. So 1 minus 1 0. This is same, you will get 3 0. 2 minus 2. So C4 you divide by 2. So conversion of the normal form will be somewhat lengthy process. So you have to make all zeros and also ones to make it as a identity matrix. So 1 0 0 0 0 1 minus 1 1 0 0 3 minus 2, sorry, minus 1, and here 0 0 0. Now again what we have to do, this one 0, this one 0, this one 0. Okay, so if you add these two, what you'll get? This it will become 0, and 3 minus 1 means you will get here 2. Okay, so C4 plus C3, what we can do? C3 first you do this one, what you will get? 1 0 0 0 0 1 minus 1. 1 minus 1 means 0. Next to 0 0 3. 3 minus 1 means you will get 2 here. Next to 0 0 0 0. Okay, now this we have to make zeros means minus 1 plus 1. That is C3 is C3 plus C2. Okay. One zero 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 one minus one plus one is zero zero. Next 0 0 3 2 0 0 0 0. Now what we left, 3 is there and also 2 is there. Okay. Minus 1 minus 1 0. You have to make this as 0. Okay. You can write C4. C4 is 2. 2 minus. Okay. If you multiply with 2 by 3, what you will get? 3 will get cancelled. 2. So minus 2 by 3 into C3. Okay. See, C4 is 2. 2 minus 2 by 3 into what is C3? 3. So 3 will get cancelled. Then 2 minus 2 is 0. So you will get here 1 0 0 0 0 1 0 0 0 0 here 3. Next this is 0 0 0 0 0. Okay, we have made all zeros. Now the left is, you have to make this as 1. Okay, then the identity matrix, you will get 3 by 3 identity matrix. So that is R3 by 3. So then what you will get? Okay, we got I3. See here, we can't convert it into I2, that is 2 by 2 identity matrix. So we can't do the subtraction of here to make it as 0. 1 here it is, element is not there. Even in the column also you have not having the same element as 1. Okay. So here the identity matrix we are converting, the given matrix is I3 we got. Okay. So it is equals to, so this is the procedure of finding the any matrix, to find the rank of the matrix by reducing it to normal form. Okay, like this we can write. So here the order is 3. Identity matrix is of order 3. So therefore rank of A equals to, so we got I3. So in some problems you may get I2 also, means this also it will become 0. So only I2 matrix, that I 2 by 2 identity matrix. Then the rank of matrix is 2. Okay. So whenever it is a 4 by 4 matrix, so you may have 4 as or rank or 3 or 2 or 1. Okay, it depends on the cases. So if first check not equals to 0 means 4. If all the 3 by 3 minus in that any one is not equals to 0, then rank is 3. If it is equals to 0, then check 2 by 2 matrices. So we have done this lengthy process. So if you know before only, you may some cases you may not get in the form of 3 by 3 identity matrix. Then if you know before only the rank of the matrix, then it will be easy for us to convert it into identity matrix. Okay, here you can't make this way 1 as 0. Okay, so if you would have making this as a 0, then the rank would be 2. But here the chance is not there. R3 minus R2 or R3 minus R1, you will not get this as 0. Or C, if you will do the column operations also, then also you will not get it as 0. Okay, so we have done only single operation, so the process has become very lengthy one. So you can add at the same 2 operations or 3 operations at a time. So whatever the operations I have done, you know, no need to follow that operations only. Okay, you can select any operations other than this, but follow the rules of the elementary transformations and convert the given matrix into normal form and find the rank of the matrix. So normal form problem you may get for 10 marks, or simple rank of a matrix, that is converting into echelon form, you will get for the 5 marks problems. And you have the chance of asking many multiple choice questions, even match the following, and also in the fill in the blanks also they'll ask what is the rank of the zero matrix or null matrix, or what is the rank of a singular that is 1 by 1 matrix, or if it is a singular matrix, then what is the rank? If it is a non-singular matrix, then what is the rank? So like that you will get the even multiple choice questions also. So this is the 7th unit. In this only we have echelon form conversion is there, finding the rank is there, and also reducing to normal form. Okay. If you see the unit 8, it is the system of linear equations is there. Okay. System of linear equations. So while telling the introduction, I have told this one. And even if you have the textbooks in unit 7, you see one theorem is there on elementary transformations. That is the rank of the matrix, every transformation, that is elementary transformations, do not alter the rank of a matrix. This is the 10 marks theorem you have compulsory. They will ask in the examinations. Elementary transformations. Not alter the rank of. Okay, this is the theorem you have. You have on page number 75. Okay, elementary transformations do not alter the rank of the matrix. This is the 10 marks theorem. Okay, you know already that 3 series will be there. Okay, there is A, B, C. So you will write any one series in this. So in any one series, compulsory this one theorem you will get as a 10 marks question. Okay. So other, if you are getting this one in A, B, you may get the normal form. Okay. Or in C, you may get the Cayley-Hamilton theorem. But the thing is, compulsory this in any one series you will get this question for 10 marks question. Okay. C is the proof of the theorem you have in your textbook. So it is almost 2 pages it is there. So try to practice that one. And the meaning of this theorem is, that is elementary transformation do not alter the rank of the matrix. Means if you apply the elementary transformations to the given matrix, it does not change the rank of the matrix. Okay. We have seen just a shortcut method now to find the rank. If rank of the matrix with the shortcut method, you're checking that one. If you got the rank as 3, then while doing the elementary operations, the rank will not change. That means it will be 3 only. So this operations does not change the rank of the matrix. So first, if it is a 4 by 4 matrix, it is there. Then you may it may be converted into 3 by 4, because one row or one column you may make it as zeros. Okay. So equivalent matrix means going on converting the matrices into forms. At last you will get the identity matrix of 3 by 3 order. So therefore the rank is 3 here. That is the meaning of this theorem. So proof, you have different cases are there. So in that cases we'll show that the theorem is true. Okay, that is the proof of this theorem. 75 page number it is there. When you will get the textbook, you see this one. 75 page number and this theorem. Okay. And practice all the normal form problems, and also echelon form problems are there in your textbook. And here whatever the rules are there for rank of the matrix, and also elementary transformations, and also echelon form, normal form, These all you will get for multiple choice questions. Why? Because in this all are problematic. Only one theorem is there. So therefore you will get the 2 to 3 objective type questions. 5 marks you may get rank is there, and the 10 marks is this theorem or conversion into normal form. Okay. So 10, 15, 16, 17 marks, almost 17 marks you will get from the unit 7. Okay. So try to practice this one. So tomorrow we'll see the system of linear equations. So we'll try to complete tomorrow 8 and 9th unit. So one problem, just I will tell the what is the frame of the system of linear equations, and I will tell just one problem in that. So you practice other problems. So linear equations problem is also 5 marks question. In that while telling the introduction, I have told homogeneous linear equation will be there, and also non-homogeneous linear equation will be there. Okay. So homogeneous, you have homogeneous and non-homogeneous, almost the method will be same. Just finding the solutions will be different. Okay. So anyone will be 5 marks question. So in 8th unit, only 5 marks question you will get after the linear equations. So examples are there, and also check your progress also there. Okay. So non-homogeneous, in that some cases they will ask for 10 marks question. Non-homogeneous means here whatever the constant values will be there, that values will be there. With the help of that, even homogeneous and non-homogeneous system of linear equations is also used for finding the rank of the matrix and also solutions. So you may have the chance of 5 or 10 marks. Okay, in unit 8. Okay, we'll see 2 problems tomorrow, and also we'll complete the 9th unit also. 9th unit you have characteristic roots and characteristic vectors, but in this 9th unit Cayley-Hamilton theorem is there. Okay, Cayley-Hamilton theorem you have the chance of compulsory, not chance, you have you will get Cayley-Hamilton theorem, state and prove the Cayley-Hamilton theorem for 10 marks question. Okay, so 7th and 9th unit you will get the 10 marks questions, and from the 7th unit you will get 5 marks question. Why? Because in each block you will get 2 5 marks questions and 2 10 marks questions. Okay, so one will be from 7th unit and one you will get from 8th unit here, 5 marks questions. Okay, but while for the 10 marks questions you will get one from 7th unit and compulsory from 9th unit. Okay, so 3 questions. No, in 3 series they will ask. So you will get here in 7th unit 5 marks question, even in A series, B series and C series. Okay, so here whatever 9th unit 10 marks is there, in that state and prove the Cayley-Hamilton theorem. In one series you will get, in another series you will get verify Cayley-Hamilton theorem. So Cayley-Hamilton theorem, whatever the proof is there, with the help of that you have to prove the given matrix, verify that whether it is satisfying the Cayley-Hamilton theorem or not. So that will be the 10 marks question, either this question or that question you will get. Okay, so from block 3, so 5 2 marks, that is 2 5 marks questions and 2 10 marks questions you will get. Okay, here 1 10 and here 5 5 10 20 24. So each unit I have told already 25 26 marks you will get. Even you may have chance of getting 3 questions 5 marks questions also. Why? Because these are all problematic one. They will ask the 9th unit also, quadratic characteristic roots is also there, no, that also we will get for 5 marks. So tomorrow we'll complete almost 8th and 9th unit. Okay, so next we have only one class of linear algebra. On that day we'll complete the block 4. If we start, we'll see the problems on that. After that we'll see the 3D. Okay.